Algebra 2, Chapter 10.3, Solving Rational Equations. Essential question, what methods are there for solving rational equations? So this section 10.3 builds upon section 10.1, which is adding, subtracting rational expressions, and section 10.2, which is multiplying, dividing rational expressions. Now, solving rational equations is where we're going to put into practice what we learned in sections 10.1 and 10.2, and combinations with factoring and other techniques of algebra to solve equations. And basically, what methods are there for solving rational equations? Well, the two we're going to examine here are: one, we're going to solve rational equations by graphing, and then also we're going to solve algebraically. Okay, the first section here, solving rational equations graphically. And first example here is solve the rational equation x over x minus 3 equals 2 by graphing. The first thing we look for here is to find out what our excluded values of x are. And to do that, if we set our denominator equal to 0, what I like to do is, instead of setting this denominator, in this case x minus 2 equals 0, I like to set it equal to, not equal to 0, because when we put not equal to, that tells us what x cannot be, and has within the statement, in fact, that 3 in this case is the excluded value. X cannot equal 3. Over here in part B, so 3 is the excluded value of the rational equation. Rewrite the equation with 0 on one side. And to do that, we're going to subtract 2 from each side of this rational equation. So we have x over x minus 3 minus 2 is equal to 0. And the next step we're going to do is we're going to change this 0 to f of x, or y, and then graph. And so we substituted y for 0. So if we take this equation here and substitute in 0 for x, we're going to have 0 over 0 minus 3 minus 2. Well, that's going to be negative 2. So our xy coordinate pair is 0, comma, negative 2. And then likewise, we go about it for these other input values. So for the next one, for 1, we have 1 over 1 minus 3 minus 2. And that's going to be equal to 1 over negative 2, so that's negative 1/2, minus 2 is going to be negative 5/2. So that's going to be the 0.1, comma, negative 2.5. And we can likewise do the same for 2. We have 2 over 2 minus 3 minus 2. So we get 2 over negative 1, which is negative 2, minus 2, which is negative 4. So we get 2, comma, negative 4. And if we use 4 over 4 minus 3 minus 2, we get 4 over 1 minus 2 is 2. So we're going to get 4, comma 2, and then for 5 over 5 minus 3 minus 2, we're going to get 5/2 minus 2, which is going to be 1/2. So we get 5, comma 1, I'll put 0.5. And for 9, we put in 9 over 9 minus 3 minus 2. It's kind of hard to read there. It's 9 over, which is going to be 9 over 6, or 3 halves minus 2. So we get negative 1 half. So we're going to get 9 comma negative 0.5. Now part D, use the table to graph the function. Well, our excluded value is x equals 3, and so I'm going to just draw a dashed line here at x equals 3, which is going to be our vertical asymptote. So I'll put up here x is equal to 3, and that's going to be our vertical asymptote, abbreviating VA. And now for the points here, we have 0, negative 2. That's our y-intercept. Then we have 1, negative 2.5. We have 2, negative 4. And so what we have over on this side, we have this. That's what this thing looks like here. And then on the right side, we have put in 4. We get 4, 2. So there's 4, 2. We have 5, 0.5. So there's 5, 0.5. And we have 9, negative 0.5. So on the right side, we're going to look like this. And then it says, identify x-intercepts of the graph. We cannot see an x-intercept, but it looks like 6 might be. And I'm going to demonstrate with the calculator that 6 is. So this point here, 6, 0, and is the value of, there's an x-intercept at, I'm going to put here 6, 0. Is the value of x an excluded value? What is the solution? We have x equals 6 is our solution, not an excluded value. And we're going to talk about what that means. And then in a calculator, this is what it looks like. Here's the equation entered here in the function editor. We graph, we can see an x-intercept. We can find that graphically by going second trace 2, which is 0. As question left bound, we arrow to the left of our x-intercept and press enter. It says right bound, we go to the right. We press enter twice, and we see the point 6, 0, and we can go to the table. Also, press second table, we can see the point 6, 0. So that's how we can solve by graphing, and we can solve rational equations and just about any other equation you can think of by graphing. So that's a technique that you can bring to bear for just about anything you do. Okay, now to the next phase, which has to do with identifying the LCD, and LCD stands for least common denominator. At least common denominator, the concept is helping us to solve equations, and to solve equations, rational equations, we're going to need to multiply by the least common denominator. So that's the purpose of this exercise. So we're going to do this in a couple of instances. Here they give a couple examples, example A and example B, and I'm going to go ahead to just, it says your turn, number 3 and 4. So what we're going to do is look for each denominator. So we're going to factor this first one, which is 8x minus 24. And the factors of that, the common factor is going to be 8. So we have 8 times quantity x minus 3. And then we have this 10x minus 30. And that's going to be equal to the greatest common factor here, which is 10 times x minus 3. And so between these things here, we have x minus 3 is common between these two, but 8 and 10 are not. And so to get a least common denominator between these two, we're going to have 8 times 10 times quantity x minus 3. So our least common denominator is going to be equal to 80 times quantity x minus 3. And this would be helpful to us if we're going to solve rational equations. And then we have this other one. I'm not even going to do example 4 here. Next, solving rational equations algebraically. Already we solved a rational equation graphically. What we're going to do first is look for excluded values. And excluded values, if they turn out to be solutions, are going to be called extraneous solutions. And they are not real solutions of an equation, but are solutions that are created in the process of solving the equation. So almost you have to see what it looks like. And here they give this example of solving each rational equation algebraically. The first thing is finding an excluded value, identifying the least common denominator, and then just kind of working your way through. And then we multiply by that least common denominator and just solve the equation. Here you went through all the process. You ended up with x plus 14 equals 17. In solving for x, x equals 3, and 3 was not our excluded value. So here we're given an example of this one here, 2x minus 9 over x minus 7 plus x over 2 equals 5 over x minus 7. And the excluded values are, of course, x minus 7 cannot equal 0, so x cannot equal 7. So also x cannot equal 2 because we cannot divide by 2 anywhere. So excluded value is x cannot equal 2, x cannot equal 7. And identify the LCD. Well, LCD, different factors are going to be 2 and x minus 7. So the LCD is 2 times quantity x minus 7. So now we're going to multiply this out to multiply each term by the LCD, 2 times quantity x minus 7. And this one here, 2 times x minus 7. And then we have times 2 times quantity x minus 7. And then we cancel this x minus 7 here. We'll cancel that one. In this case, 2 times quantity x minus 7. Okay, this is going to cancel. The 2 will cancel. And this one here, 2 times quantity x minus 7. The x minus 7 cancels. So what we have left is simplify. We have 2 for this first one. We have 2 left over. And then for this x, we have x times quantity x minus 7. And we have 5 on the right times 2. And then, so we end up, we're here on the left side with 4x minus 18 plus x squared minus 7x, because x times x is x squared, x times negative 7 is negative 7x, equals 10. So to write in standard form, we're going to subtract 10 from both sides of the equation. So what we're going to end up with is, on the left side, x squared, and we have plus 4x, and then we have negative 18 minus 10 is going to be minus 28. And on the right side we have 0. And so factoring x and x, so we're going to have negative 28. So we're going to have a negative times a positive to get negative 28. So what two numbers multiply together equal negative 28, but when added together equal 4? Let's see, what are the factors? 28, 14, and 2, 7 and 4. Would that be right? Seven and 4. Let's see here. Let's see here what we got. We should have got minus 3x somehow. That's 2x. Yeah, that's because that's plus 2x, x minus 7, 4x minus 7x. Yeah, that's what it is. So this is going to be minus 3x. That looks better. So now we're going to have 7 and 4. So minus 7 plus 4. So we have x minus 7 equals 0, or x plus 4 equals 0. So we have x minus equals 7, or x equals negative 4. The solution x equals 7 is extraneous because it's an excluded value. The only solution is x equals negative 4. Okay, let's go on here. Your turn. Solve each rational equation algebraically. So I'll just go ahead and pause the video, and then you can pause and then work ahead and see if you got it right. Okay, your excluded values x cannot equal negative 3, and also x cannot equal negative 6. Okay, and our least common denominator is going to be quantity x plus 3 times quantity x plus 6. So now we can just work this out. So this 8 times, and the concept we're doing here is clear the denominator. So we multiply the left side by this x plus 3 times quantity x plus 6. And on the right side, we take this x plus 1 over x plus 6 and multiply it by quantity x plus 3 times quantity x plus 6. And so we have cancellations here. And so x plus 6 over x plus 6. And on the left side, what we have is 8 times x plus 6 equals x plus 1 times quantity x plus 3. And on the left side, we have 8x, and 8 times 6 is 48. And on the right side, we have x squared, and we have plus 1x plus 3x, so that's going to be plus 4x. And then 1 times 3 is plus 3. And now we're going to get in standard form by subtracting 8x and subtracting 48. That's 8x, not very legible, so minus 8x minus 48. And then we have 0 on the left side now. On the right side, we have x squared, and we have 4x minus 8x, which is minus 4x. And then 3 minus 48, which is going to be negative 45. And now factoring, 0 is equal to x and x, and we have negative 45, so we're going to have minus plus. Now, and minus 4x, so what two numbers multiplied together equal negative 45, but added together equal negative 4? I'm thinking 9 and 5. So if we have quantity x minus 9 times quantity x plus 5, that should work out. So we have, I'm just going to kind of bring it up here. So we have x minus 9 is equal to 0, and we have x plus 5 is equal to 0. So we have x is equal to 9, and x is equal to negative 5. And neither of these is an excluded value from our original work. So, therefore, our answers are going to be x equals 9 and x equals negative 5. Often you will come up with these extraneous values, so I'm going to leave it to you to look over the homework set, and that's it. I hope this has been helpful to you. Good luck, and thanks for viewing.